so much kinetic energy. Potentially.
There you go. Okay. I feel like we're stopping.
I hope we don't get stuck. Oh no.
Don't look at me like that. Miss Gossie is afraid of this.
Okay, you can do it.
Oh man.
I believe in you.
Oh my god.
Hold on till you're blowing!
Oh my god, I'm so nervous. Okay, we're okay. Still going slow. It's like kind of like a baby, right?
Yeah, it's okay. I got this.
Oh my god!
Oh my gosh, our track may end here, but our journey with kinetic and potential energy is just getting started. Oh, sorry class, sorry I was late, and sorry for my attire, but I just got out of practice with my 6th graders, love them, practicing Kinetic, and we were just practicing our kinetic and potential energy properties. Alright, so that leads into our conversation today. We are going to talk about energy. And energy is the ability to do work. And there's a very important factor that we must remember. It cannot be created nor destroyed. What did I say? Created nor destroyed. Okay? There are 2 main types of energy that we are going to discuss today. I am going to discuss kinetic energy, and Miss Gossie is going to be discussing potential. And while you are listening, please make sure you are filling out your 4-square workbook, okay? So I will be checking that, and there'll be an activity later on, so please make sure you are doing that. So, where to begin? Kinetic energy is energy that does work, okay? So there are 2 factors that influence it, 1 being motion, and 2, the more mass means the faster and the more kinetic energy the object will have, okay? So, what was kinetic energy again? It's energy that does work. You do work, I do work, we all do work, okay? So, it occurs in different forms, one being light, heat, sound, mechanical, and radiation. And now, Miss Gossie is going to come and speak to us about potential energy. Whew. Thanks for the introduction, Ms. Batdorf. All right, let's continue this journey. All right, so before we continue on, we know that energy has the ability to do work. And in order to do work, we need energy. So, for example, we all know that you can't come to school today and do your schoolwork if you don't get some energy, if you don't get some sleep. So, we're going to switch from kinetic energy right now, and we're going to transition or move on to potential energy. Potential energy is stored up energy that could do work. You see this underlined word could right here? Let me explain to you. Maybe, possibly, eventually might do some work, alright? It's not doing work currently though, or right now. So, what that means is that stored energy is influenced by position and conditions. Position is where your object is, whether it be a ball you're holding it, and maybe you're thinking about dropping your ball. Right now, your ball is in potential energy mode, okay? Because right now, it's not doing work, it's not moving, it's not in motion, it's not falling, it's in your hand, it's staying still. So, let's move on to condition now. Condition is maybe you're talking about where you're going to drop this object, or where you're going to push this object. Is it going to be a smooth surface? Is it going to be a rough surface? Is there friction? We don't know. But you guys will be able to think of some surroundings for your own experiment when we go into our lab time. Alright, so Ms. Batdorf talked about different forms of kinetic energy, and now we're going to talk about different forms of potential energy. And there's 4 main types. There's chemical, nuclear, stored mechanical, and gravitational. Now these all should be written down in your notebook somewhere, so that way when we come and check your organizer, your 4-square organizer, majority of this information should be in there, so that way you can go back to it and study. So an example of potential energy would be, let's go back to the roller coaster that me and Ms. Batdorf were on earlier.
So fun.
So fun, right? Alright, so you saw me and Ms. Batdorf chugging up this track, right? Trying to get to the top of the roller coaster so that way we eventually could go down.
when we reach the top on that roller coaster, we're in what's called potential energy again. We're not moving, we're stuck, we're getting ready to move though. And we know we're getting ready to move because we're on a roller coaster. And what do roller coasters do? They go. So, if we are at the top of our roller coaster, we're in potential energy. But if we're moving down the hill on our roller coaster, we're in kinetic energy, alright? And sometimes when we're going down, we can still have potential energy and have both energies. So, do you have any questions, Miss Baddorf, right now? Should we move on to our next part?
I think we're ready to move on.
Alright, let's move on.
Oh, here we go.
Are we Shrek? Oh.
Okay.
Can I be Fiona?
No.
Just kidding.
Okay. Anyways, we're back, class.
Alright, so here we're going to show you guys a little bit of what potential and kinetic energy look like when you're talking about a ball rolling down a hill. So it's actually really simple. Don't pay attention to the words, just pay attention to the motions and the ball. Okay? Okay. So at first you have a ball that's at the top of the hill right here, okay? This ball has potential energy but no kinetic energy right now. This ball has the option to move and it has the potential to move. It could maybe move, possibly move, it might move, but it's not currently moving yet. So when a ball is up top or wherever it may be, if there is a place for it to go, it has potential energy. Okay, Miss Baddorf.
Next, here we see the ball rolling down a hill. And here is where it has potential and kinetic energy because it is moving down the hill, so it has energy, and the potential is maybe it does or maybe it doesn't because a rock or something might come and stop it. And next, right here, we have the ball reaching the bottom of the hill, but it is still rolling a little bit. So it has kinetic energy, but no potential energy, because what do you know? It's not doing any work.
Rightio. Alright, so now, Ms. Baddorf, if I could ask you to scooch on over.
Yes.
Thank you. Our ball has reached the end of the hill. So right now, our ball has neither potential nor kinetic energy. So it doesn't have any energy unless something forces it to have energy, or something forces it to move. That's called a force. What do you know? Alright, so right now, since there's no potential, no kinetic energy, we have to say that the ball doesn't have the option to move, the ball is not moving, and it won't move unless something pushes it.
Oh, welcome back to our wonderful board of information. Okay, so please make sure you have all these notes down so that tomorrow we're all on the same page and we will have plenty of time to be doing our fun little experiment that Miss Gossi is going to explain. But please make sure that you have at least one drawing about potential or kinetic energy. So whether you take that from our fun little roller coaster ride, or from our example about the ball rolling down the hill, or feel like you practice, I mean, hey, the world is at your hands. You decide.
The world is their oyster, right?
You're right.
Right. Okay. So we're going to go and briefly talk about our experiment for tomorrow. So the things that we're going to be using tomorrow are 3 different balls with different masses, different weights. So we're going to have a ping pong ball, a field hockey ball, and a lacrosse ball. Lacrosse ball will be our heaviest ball, and our ping pong ball will, hopefully, you guys guessed it, is going to be our lightest ball. So we're going to be comparing kinetic energy and potential energy. We are going to be making ramps, and our ramps are going to be used from textbooks, tables, cardboard, whatever you guys can find available in our classroom tomorrow is at your disposal to make your ramp. So you're going to let the different balls flow down your ramp, and you're going to see which ball goes the farther distance, which ball goes farther. So you're going to be recording all the data that you collect, and you're going to be measuring and putting everything down in your data worksheet tomorrow, or data report, whatever you guys want to call it, tomorrow. So with that, we've talked about all that we need to talk about so that you guys are prepared for class tomorrow. We hope to see your bright and shining faces. Ms.
Can't wait to see. I'm so excited for this experiment. I can't wait to see what turns how it turns out, and it's going to be so fun.
It's going to be great. All right, have a good night, class.